The weights in grams of a random sample of 48 broad beans are summarized in the table. This is a class interval, the frequency and the midpoint is given. A histogram was drawn to represent these data. The 2.1 up to 2.7 class was represented by a bar of width 1.5 cm and height 1 cm. That is this one. Find the width and the height of class 0.9 to 1.1. We have to find this. So let's say we have the given classes. X is greater than 2.1 and less than 2.7, and the frequency is 2, and the midpoint is 2.4. Class midpoint is 2.4, and the width of this class interval is 2.1 to 2.7, and another class interval is, which we have to find, is this, that is 0.9 up to 1.1 inclusive. This frequency is given 9. This midpoint is given 1, class midpoint, and its width. Now what is given here is, this class was represented by a bar of, this class is represented by a bar of width 1.5. Say this is 1.5 and this is 1. Let's say it's represented by this. So this is 1.5 and this height is 1. So we have to find the bar for this class interval, so that what will be its height and what will be its width. This we have to calculate, and this is the information given to us. Now in this one, the width according to this is, so this is 2.1 up to 2.7, and this is 1.5, this is 0.9, this is 0.9, this point and this point is 1.1. So this length is, so actually this length is 2.7 minus 2.1, so that is, this width is 0.6, and this width is 1.1 minus 0.9, so this is 0.2. Now what it's saying is, this is representing frequency density 2. The frequency, this frequency 2, and this one is representing the frequency 9. So this area is this width 1.5 multiply 1, that is 1.5 whatever unit square. This represent frequency 2. So we can say that 1.5 represent frequency 2. So 1 will represent, not 1, we need 1 frequency. So we just rewrite it that frequency 2 is represented by 1.5 unit square. So frequency 1 will be represented by 1.5 over 2, that is 0.75. This one. So frequency 9 is represented by 0.75 multiply 9 by this area. So that is equal to that is 6.75 unit square. So this is the frequency, this must be the area of this histogram. So this area is equal to 6.75. Now we know the area. The only thing is either we know this width or we know this height. If we know any of this, it will be easy for us to draw this histogram. Now we know the area. So the area may be this, it may be this 6.75, 6.75. We have to calculate it. Now for this we have this clue which is going to help us. This width is 0.6 and this width is 1.5. So what we can say is 0.6 is represented by 1.5. So 1 is going to be represented by 1.5 over 0.6. And this is 0.2 is going to be represented by into 0.2. So that is, it's easy even mathematically. 3 parts of this, 3 parts of this. So that is equal to 0.5. So this width is 0.5. So the height will be 6.75 over 0.5. So the height will be 6.75 over 0.5. So that is equal to 13.5 unit. So this histogram is having this 13.5 and it is it's roughly this 0.5. So this one. Part B is give a reason to justify the use of histogram. Now because we can see it's in the continuation. So data is continuous. So which justify the use of histogram. Estimate the mean and the standard deviation